Welcome, everybody. This is an exercise in looking at leap year. And you should be at a spot where when I talk about a leap year or a leap day, that means something to you. But this exercise just kind of walks you through a few things. One, can you calculate when a leap year would be? And you should have a decent understanding of why we have them and what they are. So basically, a leap year, it's going to be a year where you have an added day into February, which is referred to as a leap day. And that's going to show up on the calendar as February 29th. So not every year is going to have this. The reason that we have this is because if I said, how long is a year? Most kids would either say, well, it's a full revolution around the sun, or it's 365 days. And, under normal circumstances, those are perfectly acceptable answers. But if we look at that 365 days and we say, okay, well, it takes 365 days to revolve around the sun, the problem is that's not exact. And to be exact, it actually is 365.242199. And I get that 0.242199 days doesn't really seem like a whole heck of a lot. Or over the course of a year, that works out to be about 5 hours, 48 minutes, and 46 seconds. So that's not something that we would probably notice. But the thing is, if you keep having 5 hours, 48 minutes, and 46 seconds off per revolution or per year, year after year after year, that does add up. And what you can end up happening is cultural events or things like equinoxes and solstices, they don't align with what your calendar is. So it's important to keep in mind that a calendar is a lot like a map. If we say it's spring, that's talking about a time, but it's also talking about that location and space. So if those two things don't equal, it's a problem. So here's how this kind of went down. It was noted that things were getting off, and Julius Caesar came up with Julian Calendar, or actually gets credited with the Julian Calendar. It was actually astronomers or timekeepers back in the day that came up with it, and they noticed that there was off, or that there was something that was amiss. There was a mistake here. Like the calendar was saying one thing, but what they observed in nature was not jiving with that. So they got together a group of astronomers, they basically being Julius Caesar. And what they had determined is it is not 365 rotations in a revolution, which is to say there's not 365 days in a year. They determined that it was actually 365.25. So 0.25 decimal wise, right? Fraction wise, that's a quarter. So what they figured was, all right, well, if there's an extra quarter of a rotation per revolution, or an extra quarter of a day per year, 1 quarter, 2 quarter, 3 quarter, 4 quarter, we should be able to just have an extra day or an extra rotation every 4 years. Well, that's what they did. And they came up with the Julian calendar, and it stood for quite some time. But the problem is we're not at 365 days per year. We're not at 365.25. It works out to be 365.242199. So the difference between this 0.25 and this 0.242199, it adds up to be about, again, ballpark 6 hours off every year. So they came up with this Julian calendar in about 46 BC. Stood. That little bit of a difference didn't really get too noticed until around the late 1500s, about 1582 or so. Pope Gregory and astronomers and people alike noticed that we're at the exact same problem. Things are off. What we're observing isn't matching what the calendar says. And they're about 10 days off. So the Gregorian calendar, which is the one that we actually use today, got together a group of astronomers, and they really just lopped off about 10 days, and they wanted to reset what the equinox was. So they put March 21st back on what should be the March 21st, or the equinox. And that's the way that we still do things today. So it kind of seems like it's trivial, But again, you got to keep in mind that over long periods of time, you could have a calendar that gets off further and further and further, and that can be problematic. So here's the way that the Gregorian calendar, the calendar that we still use today, rather than just saying every 4 years we're going to have an extra day, it says, look, if the year's evenly divisible by 4, the calendar year, cool, it's a leap year. If it ends in double zero, so like 1900, year 2000, year 2100, year 1600, it has to also be evenly divisible by 400. So there's this extra little caveat, and that ends up keeping us pretty darn accurate for quite some time. Not 100% perfect for all eternity, but we're not going to have to make any adjustments to this for quite some time. So the examples I gave you here, right? I got year 2012. So if I put in 2012, and I ask myself, is it evenly divisible by 4? Let's find out. Divided by 4. Got 503. There's no remainder. There's no decimal there. So I'm going to say yes. It's kind of irrelevant, but no, it does not end in double zero. So I don't really care if it's evenly divided by 400. This would have been a leap year. So if I look at the year 1900, all right. So if I go 1900 divided by 4, 475. Okay, so let's see what's going on here. Yes, that is evenly divisible by 4. Does it end in double zero? Yes. So let's see if it's also evenly divisible by 400. 1900 divided by 400. Womp womp. We got a decimal here, right? Or it's not evenly divisible. We've got some left over there. So I would have to say no. Non-leap year. And this is the way that you go about calculating whether or not something is a leap year by the Gregorian calendar, which is still the same calendar that we use today. Rather than show you every single step, I've posted a key on my site from here on out. If you got any questions, feel free to see me in class or shoot me an email. As always, bye-bye.